November 12, 1942. Richmond, California. A complete cargo vessel, 441 feet long and weighing 28,490,000 pounds, stood ready to slide into San Francisco Bay through the gates of Permanente Metals Corporation, Yard No. 2. The ship had been assembled in just 4 days, 15 hours and 29 minutes. In traditional shipyards, master builders had spent 6 to 8 months constructing vessels of similar size since before the American Revolution. Yet here, a complete Liberty ship stood ready for service. Over 1,000 workers stepped back from the hull of the SS Robert E. Peary. Not traditional shipwrights, not experienced maritime craftsmen, but former secretaries, farmers, housewives and laborers who had learned welding techniques just weeks earlier. The crowd of officials, journalists and competing shipyard owners had gathered to witness a moment that would trigger a profound transformation in industrial production, a systematic revolution through American manufacturing innovation that would echo across decades. The mathematics of Allied victory were being written not in battle strategies, but in production statistics that would shatter every assumption maritime experts carried about shipbuilding limits, construction timeframes, and industrial possibility. The transformation had begun on December 27, 1940, when Henry J. Kaiser signed his first shipbuilding contract. A man who had never built a ship, never managed a shipyard, and had spent his career moving earth and pouring concrete for massive dam projects across the American West. Yet here stood a 58-year-old construction magnate who had just promised the United States Maritime Commission he would build 30 cargo vessels for the British government within 2 years. Traditional shipbuilders dismissed him as a naive opportunist. The Todd Bath Iron Works, one of America's oldest shipyards, had reluctantly agreed to partner with Kaiser on the project, assuming their expertise would compensate for his ignorance. What none of them understood was that Kaiser's lack of shipbuilding experience would become his greatest advantage. Among those watching was William Francis Gibbs, America's most respected naval architect, whose firm Gibbs & Cox had created the Liberty ship plans based on British designs. He had designed more ships than Kaiser had probably seen. The journey from skepticism to revolution began in the planning offices of Todd Shipyards in New York. As Kaiser and his engineers examined traditional shipbuilding procedures in early 1941, they recognized immediately that conventional methods would never meet wartime demands. Kaiser's chief engineer, Clay Bedford, had visited a Ford Motor Company assembly line in Detroit just weeks before. Bedford had watched automobile chassis moving down production lines, with workers installing prefabricated components at each station. He had returned to California convinced that ships could be built the same way. The traditional shipbuilders considered this comparison absurd. The first real shock came with Kaiser's proposal to eliminate riveting entirely. Traditional ship construction relied on rivets, heated metal pins that were hammered through overlapping steel plates to join them together. A skilled riveting crew, working with perfect coordination, could install perhaps 100 rivets per day. Each Liberty ship required approximately 1 million rivets if built conventionally. Kaiser proposed using electric arc welding instead, a technique he had mastered building pipelines across the American West. Vice Admiral Emory Land, chairman of the United States Maritime Commission, examined Kaiser's proposal with deep skepticism. His private correspondence, preserved in the National Archives, revealed the maritime establishment's reaction. Welding has never been proven reliable for hull construction at this scale. The British Navy forbids welding on warship hulls. Kaiser is proposing we bet America's supply lines on an unproven technology. Yet Land also recognized desperation. German U-boats and surface raiders were sinking Allied shipping faster than traditional shipyards could replace vessels. In 1941 alone, approximately 3.6 million tons of Allied shipping would go to the ocean floor from all causes. Britain was literally starving. American shipyards, using conventional methods, would require an average of 230 days to build a single cargo ship. At that pace, the Allies would lose the Battle of the Atlantic before American industry could respond. The decision to approve Kaiser's contract represented not confidence, but necessity. The Richmond shipyard rose from empty mudflats between January and December 1941. Kaiser's construction crews, experienced in building dams and highways, erected a facility that horrified traditional maritime engineers. Instead of the massive gantry cranes and longitudinal building ways that characterized established shipyards, Richmond featured something entirely different. The yard was laid out like an automobile assembly plant. Open areas for prefabrication surrounded 7 parallel building ways. Railroad tracks crisscrossed the facility, designed to move massive steel sections weighing up to 150 tons. Overhead cranes capable of lifting entire ship sections stood every 100 feet. John Riley, chief naval architect for Bethlehem Steel Corporation and a 30-year veteran of shipbuilding, visited the Richmond yard in May 1941. His inspection report, marked confidential at the time, contained technical criticism and grudging admiration. Kaiser has violated every principle of efficient shipyard layout I learned in 3 decades of experience. His prefabrication areas are too large. His crane capacity is absurdly excessive. His building ways are too short. Yet I must admit the facility is designed for exactly what he claims: rapid assembly of prefabricated sections. The arrival of workers provided the next phase of revolutionary change. Traditional shipyards recruited from established maritime communities where skills passed from father to son across generations. Kaiser advertised in newspapers across America, offering wages 20% above standard industrial rates and promising to train anyone willing to work. The first groups arrived in Richmond in August 1941. The simplification of complex tasks into repeated simple operations, borrowed directly from assembly line manufacturing, proved devastatingly effective. By October 1941, Kaiser employed over 10,000 workers in Richmond, with fewer than 200 having any previous maritime experience. Traditional welders spent 4 years as apprentices learning comprehensive skills. Kaiser's instructors taught specific techniques for specific tasks in approximately 2 weeks. Workers didn't need to know how to weld everything, only how to weld the vertical seams on bulkheads, or horizontal deck plates, or curved hull sections, which they would do repeatedly. As workers gained experience through late 1941 and early 1942, something unexpected occurred. The construction time for Liberty ships began falling dramatically. Kaiser's first Liberty ship took 197 days to build and deliver. Ship number 2 required 169 days. Ship number 5 required 128 days. Ship number 10 required 97 days. By spring 1942, Richmond was completing Liberty ships in 70 days on average. Traditional shipyards watched with growing alarm as this untrained workforce achieved production speeds that matched their own highly skilled crews. The prefabrication approach that traditional builders had dismissed proved its power. Instead of building ships from keel to deck in sequence, Kaiser's yards fabricated entire sections simultaneously across the facility. While one crew assembled a bow section in the prefabrication area, other crews built stern sections, deck houses, engine rooms, and bulkheads in parallel. When sections were complete, massive cranes lifted them onto the building ways where welding crews joined them together. Albert Wooding, production supervisor at Richmond Yard No. 2, explained the efficiency in a 1943 interview with Fortune magazine. In traditional shipbuilding, you cannot install the engine until the engine room is built. You cannot build the engine room until the hull is complete. Everything happens in sequence. Kaiser's approach allows parallel production. While one crew welds hull plates, another crew assembles the engine in a separate area. When both are ready, we drop the completed engine into the completed engine room and weld it in place. Tasks that previously required weeks now take hours. The statistics of parallel production revealed manufacturing efficiency that seemed impossible to traditional builders. A conventional shipyard might have 50 workers attempting to install an engine over 3 weeks, working in the cramped confines of a partially complete engine room. Kaiser's prefabrication approach assigned 200 workers to assemble the complete engine and its mounting structure in an open workshop over 5 days, then used cranes to position the entire assembly in a single 8-hour operation. More disturbing still to traditional maritime authorities was the casual elimination of centuries-old shipbuilding practices. Ships had always been built from carefully drafted plans that specified every detail. Kaiser used simplified drawings that provided basic dimensions and left details to workers' judgment. Traditional builders considered this recklessness. Kaiser called it flexibility. Vice Admiral Howard Vickery, vice chairman of the Maritime Commission and a career naval officer, initially fought against Kaiser's simplified specifications. His transformation from skeptic to supporter, documented in commission meeting minutes, illustrated the power of results over theory. In January 1942, I opposed Kaiser's request to reduce drawing specifications. Ships are not automobiles. Maritime construction requires precision. But by March, Kaiser's yards were outproducing our traditional contractors by 40%. By June, the gap had widened to 70%. I learned that perfection is the enemy of sufficient. Kaiser's ships were not beautiful. They were adequate, and adequate ships delivered more cargo than perfect ships still under construction. As construction speeds increased through spring and summer 1942, competition developed among Kaiser's 7 shipyards spread across California, Oregon, and Washington. His son Edgar, who served as vice president and general manager overseeing all Kaiser shipyards with particular focus on the 3 Pacific Northwest facilities, managed the Oregon Shipbuilding Corporation in Portland. Clay Bedford oversaw the Richmond yards in California. The 2 men, both driving and ambitious, began an informal contest to see whose facility could build ships faster. The race between Richmond and Portland became a public spectacle through fall 1942. Newspapers published updates like sports scores. Competition records fell repeatedly until Oregon Shipbuilding built the Joseph N. Teal in just 10 days in September 1942. Vice Admiral Vickery eventually ordered the speed competitions stopped, declaring them stunt demonstrations that distracted from actual production goals. But the competition had served Kaiser's purpose. Workers across all 7 yards now believed that extraordinary speed was not merely possible, but expected. November 1942 brought the ultimate demonstration. Vice Admiral Land, visiting Richmond to inspect production, made an offhand comment to journalists that was overheard by Clay Bedford. The Admiral remarked that Liberty ship construction had improved remarkably, but noted that the recent speed record still paled compared to what mass production had achieved in other industries. Bedford took the comment as a challenge. He proposed to Vice Admiral Land that Richmond Yard No. 2 would attempt to build a complete Liberty ship, from keel laying to launch, in under 10 days, cutting the Joseph N. Teal's record in half. Land, skeptical but intrigued, authorized the attempt on condition it not disrupt regular production schedules. Bedford selected the 47th hull to be built at Yard No. 2 for the record attempt. The ship would be named SS Robert E. Peary, after the Arctic explorer. Starting Sunday, November 8th at 1 minute past midnight, over 1,000 workers operating in carefully coordinated shifts would attempt something unprecedented in maritime history. The prefabrication strategy reached its ultimate expression during the Peary construction. Every major component had been built, inspected, and staged before the keel touched the building way. The bow section, comprising more than 50 individual pieces, had been fully welded and equipped with anchor hardware, chain lockers, and forward crew quarters before assembly began. The stern section included the completed steering gear, propeller shaft, and aft crew spaces. 4 complete cargo holds, each one a massive rectangular structure of steel, waited to be lifted into position. The engine, a 140-ton triple-expansion steam power plant built by Joshua Hendy Ironworks in Sunnyvale, had been mounted on its foundation structure and tested before leaving the factory. Where conventional shipyards built from keel to deck over months, Kaiser's yards assembled a nearly complete ship from prefabricated sections in days. 4 days into construction, the hull was complete. Engine installed, deck houses positioned, cargo holds secured, steering gear mounted. On Thursday, November 12th, at 3:30 p.m., just 4 days, 15 hours, and 29 minutes after the keel touched the building way, SS Robert E. Peary slid down the launching rails into San Francisco Bay. The ship was delivered for service on November 15th, setting an additional record of 7 days, 14 hours, and 32 minutes from keel laying to full delivery. The crowd of observers included maritime officials, military officers, competing shipyard owners, and journalists from across America. Many arrived expecting to witness either failure or a compromised vessel that looked complete but lacked functionality. What they saw instead was a fully operational ship that required only minor fitting out before entering service. Vice Admiral Land, present for the launching, made brief remarks that were recorded by newsreel cameras. His words captured the maritime establishment's forced recognition that everything had changed. 6 months ago, I would have called this impossible. Traditional shipbuilding wisdom, accumulated over 3,000 years, said you cannot build a proper ship in 5 days. Henry Kaiser has made traditional wisdom obsolete. The United States Maritime Commission will now require all contracted shipyards to adopt these methods. The psychological impact on traditional shipbuilders was profound and immediate. The same yards that had dismissed Kaiser as an ignorant outsider just 18 months earlier now sent engineers to study his approaches. The president of New York Shipbuilding Corporation, one of America's oldest and most prestigious yards, visited Richmond in December 1942. His confidential report to his board of directors revealed complete ideological collapse regarding traditional approaches. Kaiser has achieved what our industry considered impossible by refusing to accept our limitations. He treated shipbuilding as a manufacturing problem rather than a craft tradition. He simplified where we sought perfection. He standardized where we customized. He trained masses of unskilled workers where we cultivated generational expertise. The result is ships built in 1/10 the time at 2/3 the cost. We must either adopt his approaches or accept irrelevance. By early 1943, Kaiser's influence had transformed American maritime production. 18 shipyards across the country were building Liberty ships using prefabrication and welding. Average construction time had fallen from 230 days initially to just 42 days by mid-1943. The United States was launching 3 Liberty ships daily, more tonnage than German submarines could sink. But perhaps the most devastating challenge to traditional maritime authority came from the quality of Kaiser's workforce. The tens of thousands of women, minorities, and untrained workers who had built these ships represented a direct refutation of the old guild system that had dominated shipbuilding for centuries. At peak production in 1944, Kaiser's 7 yards employed approximately 196,000 workers. Of these, over 40,000 were women, representing a remarkable percentage of female industrial workers. By mid-1944, women comprised 27% of Richmond's production workforce. The 3 Northwest Kaiser yards alone employed over 31,000 women by 1944. African American workers numbered in the tens of thousands, employed in skilled positions including welding, fitting, crane operation, and even supervisory roles, a level of workplace integration unusual for 1940s America. The democratization of skilled work that Kaiser enabled carried implications far beyond wartime production. By proving that complex manufacturing could be performed by trained workers rather than requiring generational craft expertise, Kaiser's shipyards challenged fundamental assumptions about labor, skill, and industrial organization. Christmas 1943 provided another powerful demonstration of Kaiser's transformed industrial culture. While traditional shipyards observed the holiday with 1 or 2 days off, Kaiser's facilities maintained production schedules. But rather than simply demanding work, Kaiser's organization provided Christmas celebrations that acknowledged workers' sacrifices. At the Richmond yards, management arranged for Christmas dinner to be served in the facility cafeterias, with turkey, ham, and all traditional accompaniments provided free to workers on shift. Local churches sent carolers. The Richmond Municipal Band performed. Kaiser himself visited the yards, shaking hands with workers and personally thanking them for their service. By mid-1944, Kaiser's 7 shipyards had produced over 800 Liberty ships, but the influence of his approaches extended far beyond his own facilities. The 18 American shipyards building Liberty ships had collectively produced 2,400 vessels by this point. Victory ships, a larger and faster design that supplemented Liberty production from 1944 onward, were built using the same prefabrication and welding techniques. The total American maritime production between 1941 and 1945 exceeded 5,500 vessels, representing approximately 53 million tons of shipping. The scale of production was staggering to contemporary observers and remains impressive by modern standards. Commander Joseph Kenworthy of the Royal Navy, assigned to the British Admiralty delegation in Washington, watched American production with admiration and envy. His official reports to the Admiralty, declassified in the 1980s, captured the British perspective on American industrial dominance. The United States is building merchant shipping at a rate that exceeds the combined capacity of the rest of the world. Kaiser alone produces more tonnage monthly than the entire British shipbuilding industry. The approaches are crude by Admiralty standards. The ships are inelegant. But they float, they carry cargo, and there are thousands of them. The Royal Navy built the finest warships in the world using traditional craftsmanship requiring years per vessel. The Americans build adequate ships in weeks. Adequate multiplied by thousands defeats perfection multiplied by dozens. But perhaps the most remarkable aspect of Kaiser's transformation was what happened after the war ended. Traditional analysts expected the wartime shipbuilding boom to collapse, leaving tens of thousands of workers unemployed and hundreds of costly facilities abandoned. The prediction proved partly true. Liberty ship production ended in September 1945. By December, Kaiser's workforce had fallen from 200,000 to fewer than 20,000. The Richmond shipyards that had employed 100,000 workers at their peak stood largely empty by spring 1946. Yet the knowledge developed during the emergency program did not disappear. The prefabrication techniques, welding procedures, and parallel assembly approaches that Kaiser pioneered became standard practice in global shipbuilding. When Japan and South Korea rebuilt their maritime industries in the 1950s and 1960s, they studied Kaiser's Liberty ship program and adopted his approaches as the foundation of their yards. The massive shipbuilding facilities in Ulsan, South Korea, and Nagasaki, Japan, that would dominate world shipping construction for decades, were direct descendants of Richmond Shipyard's revolutionary practices. John Bunker, professor of maritime history at the State University of New York Maritime College, summarized Kaiser's lasting influence in his definitive study published in 1972. Kaiser entered shipbuilding as an outsider, ignorant of maritime tradition, unconstrained by conventional wisdom, and willing to apply manufacturing principles that the established industry considered inappropriate for ship construction. In 36 months, he built more ships than had been constructed in America during the entire previous century. More importantly, he fundamentally altered how ships would be built worldwide for the remainder of the 20th century. The modular construction, prefabrication, and welded assembly that Kaiser pioneered are now universal standards. Every modern shipyard, whether building container vessels in Korea, oil tankers in Japan, or cruise ships in Europe, uses approaches derived from Kaiser's Liberty ship program. The magnitude of Kaiser's achievement can be measured in statistics that reveal both the scale of the program and its remarkable success. Production statistics show 2,710 Liberty ships built across 18 American yards between 1941 and 1945, an average of 1.8 ships per day at peak production. Kaiser's 7 yards alone produced 1,490 ships, comprising 27% of total American wartime merchant shipping, built under maritime commission contracts. Construction time fell from an average of 230 days for the first Liberty ships in 1941 to 42 days by 1943, with the record holder Robert E. Peary requiring just 4 days and 15 hours from keel laying to launch. Labor efficiency improved dramatically as workers gained experience. The first Liberty ships required approximately 1.1 million worker hours to complete. By 1943, average worker hours had fallen to approximately 486,000 per ship. Kaiser's most efficient yards, Richmond Numbers 2 and 3, achieved construction in as few as 350,000 worker hours by utilizing 3-shift, 24-hour production schedules and maximizing prefabrication. Cost efficiency matched schedule improvements. The first Liberty ships cost approximately $1.75 to $2.0 million each. By 1943, costs had fallen to $1.8 million despite rising wages and material prices, reflecting improved efficiency and learning curve effects. Each Liberty ship displaced 14,245 tons fully loaded and could carry 10,800 tons of cargo. The vessels could transport 2,840 jeeps, 440 tanks, or 230 million rounds of ammunition in a single voyage. Powered by triple expansion steam engines that were deliberately old-fashioned but reliable and easy to manufacture, the ships achieved speeds of 11 knots, adequate for convoy operations. Training efficiency proved equally remarkable. Kaiser's schools trained workers in specific tasks in an average of 2 weeks. The fastest training produced productive spot welders in just 10 days. More complex positions like crane operators or ship fitters required 4 to 6 weeks of training. This compared to traditional maritime apprenticeships lasting 4 years for basic competency and 10 years for master craftsman status. The key difference was specialization versus comprehensive training. Traditional apprentices learned all aspects of shipbuilding. Kaiser's workers mastered specific, repeatable tasks that they would perform hundreds of times. The battle casualty rates among Liberty ships demonstrated their effectiveness despite skepticism about rapid construction approaches. Of 2,710 Liberty ships built, approximately 200 were lost to enemy action, a loss rate of 7.4%. This compared favorably with pre-war merchant shipping loss rates and proved that welded construction, while initially suspect, produced seaworthy vessels. Some ships experienced structural failures due to welding defects. 3 Liberty ships broke completely in half due to brittle fracture problems, representing 0.11% of production. Nearly 1,500 instances of significant brittle fractures occurred across the Liberty fleet, but catastrophic complete breaks were rare. These failures led to improved welding procedures and steel specifications that eliminated the problem by 1944. Longevity statistics provided the ultimate vindication of Kaiser's construction approaches. Liberty ships, designed as emergency vessels with expected service lives of 5 years, proved remarkably durable. Many remained in service for decades after the war. The SS John W. Brown, built in 1942, remains operational as a museum ship in Baltimore as of 2024, 82 years after construction. The SS Jeremiah O'Brien, also built in 1942, is preserved in San Francisco and participated in the 50th anniversary commemoration of D-Day in 1994, actually sailing to Normandy under its own power after 50 years of existence. A third Liberty ship, SS Hellas Liberty, serves as a static museum ship in Greece. Post-war careers of Liberty ships extended far beyond their designed lifespan. Of the approximately 2,510 Liberty ships that survived the war, Approximately 835 remained in commercial service through the 1960s. Many were sold to foreign shipping companies where they operated into the 1970s. The SS Albert M. Bow, the last Liberty ship built and delivered on October 30, 1945, was not scrapped but converted. Sold in 1964 for $65,557, it became the fish cannery ship Star of Kodiak in 1965 and remains today as the landlocked headquarters of Trident Seafoods in Kodiak, Alaska, still in existence 8 decades after construction. The economic impact of the Liberty ship program extended across American industry. The massive steel requirements drove expansion of steel production capacity, particularly on the West Coast, where Kaiser built the Fontana steel mill specifically to supply his shipyards. This mill, completed in 1942, 5 months ahead of schedule, produced approximately 700,000 tons of steel annually and established California as a major steel-producing region for the first time. The magnesium required for incendiary bombs and aluminum for aircraft were produced in Kaiser plants built to support the integrated war production effort. Employment effects rippled through communities across California, Oregon, and Washington. The city of Richmond, California, grew from a population of 23,000 in 1940 to over 100,000 by 1943, driven entirely by shipyard employment. Kaiser built Vanport City in Oregon, which briefly became the state's second-largest city, with a population exceeding 40,000, all of whom worked in shipyards or supporting industries. These boom towns, while temporary, demonstrated the transformative effect of concentrated industrial investment. Healthcare innovation emerged as an unexpected legacy of Kaiser's shipbuilding program. To provide medical care for his massive workforce, Kaiser partnered with physician Sidney Garfield to establish prepaid healthcare programs that eventually evolved into Kaiser Permanente, one of America's largest health maintenance organizations. The model of prepaid preventive healthcare pioneered in the shipyards influenced American medical practice for decades and served over 12 million members by the early 21st century. The workers themselves carried forward the lessons of the wartime experience into decades of peacetime achievement. The shipyards gave thousands of young people, especially women and minorities, opportunities to develop capabilities they would never have accessed through conventional career paths. Those opportunities opened doors that stayed open for the rest of their lives. The technological innovations developed during the Liberty ship program influenced industries far beyond maritime construction. The welding techniques refined under wartime pressure became standard in structural steel construction, petroleum refining equipment fabrication, and pressure vessel manufacturing. The prefabrication approaches pioneered at Richmond influenced construction practices in housing, bridge building, and industrial facilities. The organizational principles of parallel production, simplified specifications, and rapid worker training became foundational concepts in operations management and industrial engineering education. Professor Michael Porter at Harvard Business School, analyzing American industrial competitiveness in a 1985 study, identified the Liberty ship program as a crucial case study in rapid capability development. Kaiser demonstrated that industrial capacity is not fixed, but can be created quickly when necessity demands it. The United States entered World War II with minimal merchant shipbuilding capability. Within 24 months, American yards were producing more tonnage than the rest of the world combined. This proved that industrial infrastructure, workforce skills, and production systems could all be developed at unprecedented speed when properly organized. That lesson has relevance beyond wartime emergency. It suggests that perceived limitations on industrial capacity often reflect organizational and conceptual constraints rather than physical impossibilities. The psychological transformation that the Liberty ship program created among industrial managers and engineers proved as significant as the physical ships produced. Before Kaiser, manufacturing executives accepted conventional wisdom about production limits, skill requirements, and organizational structures. Kaiser demonstrated that conventional wisdom could be wrong, and that breakthrough performance required questioning fundamental assumptions. The Liberty ship story ultimately stands as testament to a profound truth about human capability and industrial possibility. The ships themselves, while crucial to Allied victory, mattered less than what their construction proved. Ordinary people, given training and opportunity, could achieve extraordinary results. Complex products previously requiring years of craft tradition could be manufactured in weeks using systematized processes. Industries resistant to change for centuries could be revolutionized in months when necessity and innovation combined. Admiral Chester Nimitz, commander of the Pacific Fleet, reflected on the strategic impact of American maritime production in his post-war memoir published in 1960. "We fought across 5,000 miles of Pacific Ocean supplied by ships built faster than the enemy could sink them." Japan's military planners assumed American industrial capacity was impressive but finite. They believed that if they sank enough ships, eventually American logistics would collapse and we would be forced to negotiate. They failed to account for Henry Kaiser. By 1944, we were replacing shipping losses faster than they could inflict them. The mathematics of attrition favored the side that could build 3 ships daily over the side that could sink 2 ships daily. Industrial capacity, not martial valor, determined the outcome. The Pacific War was won in the shipyards of Richmond, Portland, and Baltimore as much as on the beaches of Iwo Jima and Okinawa. In the end, Kaiser's greatest achievement was not the 1,490 ships his yards produced, but the transformation of what industries believed possible. The Robert E. Peary, built in less than 5 days, stood as tangible proof that tradition did not equal truth, that conventional wisdom could be questioned, and that revolutionary improvement required revolutionary approaches. The maritime establishment that dismissed Kaiser as an ignorant outsider in 1940 spent decades after 1945 studying and implementing his techniques. The young workers who learned to weld and fit and fabricate carried those skills and that confidence into peacetime careers that rebuilt America's post-war economy. The approaches pioneered under wartime emergency became peacetime standards that influenced manufacturing across industries and around the world. The story of how one civilian's approach made Liberty ships appear in days instead of months is ultimately a story of transformation through demonstration. It proves that the greatest revolutions often come from those unconstrained by tradition, that progress requires questioning accepted limits, and that human potential exceeds conventional expectations when properly organized and challenged. Kaiser's workers were not superior humans. They were ordinary people achieving extraordinary results because someone believed they could and organized systems that allowed them to prove it. That lesson, demonstrated in the shipyards of Richmond and validated by 2,710 completed vessels, remains relevant wherever industries face challenges that conventional wisdom claims impossible. The Liberty ships are mostly gone now, scrapped decades ago or resting on ocean floors. But the revolution they represented endures in every modern shipyard, in every manufacturing facility that uses prefabrication, in every training program that teaches specific skills quickly rather than broad expertise slowly, and in every manager who questions whether impossible truly means impossible, or simply means nobody has figured out how yet. That is Henry Kaiser's enduring legacy, carved not in steel, but in transformed understanding of what dedicated people can accomplish when freed from the constraints of tradition and challenged to attempt what experts claim cannot be done. From December 1940, when he signed his first contract knowing nothing about shipbuilding, to November 1942, when the Robert E. Peary launched after less than 5 days of construction, to September 1945, when the last Liberty ship was delivered, Kaiser proved that industrial revolutions happen not through incremental improvements, but through fundamental reimagining of what is possible. The 2,710 Liberty ships built between 1941 and 1945 carried more than cargo across oceans. They carried proof that human ingenuity, when unshackled from tradition and empowered by necessity, can accomplish the seemingly impossible.